Bismillahirrahmanirrahim. Assalamualaikum. My name is Muhammad Syafiq Akmirul bin Jais and my metric number is S51342. Today, my partner and I, who is Muhammad Hafiz HAZIQ bin Muhammad NAZRI S51287, will be presenting and explain about our topic, which is software maintenance process, and we are from group 12. So first of all, let's go through for our introduction. So for the introduction, software maintenance is defined in the IEEE 121 standard for software maintenance as a modification of a software product after release in order to correct errors, improve performance or other attributes, and also adapt to environmental changes. Nowadays, the software maintenance process is actually one of the parts of the system development life cycle, which is SDLC. It is the process of modifying software products, and also updates are done after the delivery of software products to the customer and to improve performance to the customer. So these modifications are required because of some of the reasons, such as client requirements. The customer might be asking for new functions or features in the software when the time is over. Besides, for host modification, software changes are needed to keep adaptability if any of the hardware and operating system of the target host change. Other than that, there are 4 categories of software maintenance, which are: first is corrective maintenance, second one is adaptive maintenance, third one perfective maintenance, and the last one is preventive maintenance. So all of these categories are required and needed to make modifications and updations to deliver correct faults and improve performance to the customer. Besides, it must be performed to implement enhancements and accommodate programs. So different software, different hardware, telecommunication facilities, and features can be used. So next, let's go through for the review papers. So we are gonna identify 5 review papers. So first one is an empirical study on critical blocking bugs. So actually, this research article is about software bugs that always have a negative impact on software development and maintenance. So software maintenance usually spend a lot of time fixing these bugs. Because of that, there are many research works have been done on specific types of bugs. There are also many automation techniques that have been proposed to help developers fix these bugs. So, based on some researchers that have focused on critical blocking bugs, which is CBBs, they get bug data from 5 open source projects such as NetBeans, OpenOffice, Elite, Free Desktop, and Mozilla, including the activity information of the bugs and the commit information from their Git system. After that, they divide it into 3 categories, which are CBBs, second one is NBBs, and third one is OBs. So all of these categories will be analyzed from the following aspects, which are the fix time of the bug, the experience of the developers who fix it, the importance of the bug, and the scale of the bug fix. The results show that CBBs are more important than other bugs because they have a larger repair scale and longer repair time. However, the software maintainers might be to not assign experienced developers to fix CBBs. It usually only appears in a small number of components in the project. So they also summarize the 2 reasons why CBBs block multiple bugs. Because of that, to reduce the cost of CBBs on software maintenance or avoid such bugs as much as possible, they plan to build a model to help the project maintenance staff determine whether a bug is CBB in the future. That's all about an empirical study on critical blocking bugs in the software maintenance process. Let's go through to the second one of review papers. So the second one is CC InfoVis, a clone evolution visualization system for software maintenance. Alright, so for the second one, This research article is actually about understanding the evolution of code clones in software maintenance using CCEvolvist. Actually, CCEvolvist is a system that visualizes the evolved code clones across multiple versions of a program to support the maintenance of code clones. Based on the knowledge about how code clones evolve, researchers and developers can understand the impact of code clones and also build a more robust code clone management system using this CCEvolvist. Code clones and duplicated code are created to copy and paste the existing code with or without modification. So this will cause additional effort in comprehending and maintaining a system because most of the software contains a significant amount of code clones. Because of that, CCEvolvist have been created to detect code clones across multiple versions of a program. It will visualize, highlight, and provide the evolution of code clones based on their evolution patterns with three main features. CCEvolvist also be able to support identifying a target for clone refactoring and confirming the refactored clone. So for the future work, they are gonna plan to extend and improvise this CCEvolvist to be integrated into the IDE for helping developers maintain code clones in time and allowing developers to hide or filter out certain clone categories of clone set.
Hello, my name is MOHAMMAD HAZIQ bin Muhammad NAZRI, and today I would like to present the three technical papers that I found. Okay, the first one is the refactoring for software maintenance. This technical paper explains the refactoring technique that was used as one of the software maintenance activities. This technique is used to improve the system structure and system behavior by removing unused code and shortening the code. This will decrease the opportunity for software to have a problem in future, such as a fault or bug. Refactoring also is one of the common practice used to maintain the advanced or large software system. Based on the study by Mens et al., there are 5 processes of refactoring. Okay, the first one is to identify the code entities, or in OOP or object-oriented programming we call it as classes that need to refactoring. There are 2 ways to detect which code entities need to be refactoring, which are the anti-patterns and code smells. But the anti-pattern is not a good practice if the software is using a recurring design. Okay, the second step is to utilize the major refactoring that needs to be used. After that, the utilized factoring needs to preserve the refactored system's behavior. Every refactoring needs to follow its post conditions and preconditions. Next, the effect after refactoring process need to be measured. The effect of refactoring means that the quality attributes such as a maintainability, a complexity, a flexibility, and understandability. And the last step is to count the approaches for maintaining consistency. This is because after refactoring process is finished, the risk of impact on consistency between the source code and other software artifact like documentation, design model is so high. Okay, the next title for the technical paper is the visually exploring software maintenance activity. This technical paper is explained about using visualization in software maintenance activity. Based on this technical paper, there are three main software maintenance activities, such as a corrective, a perfective, and a adaptive. The corrective is used to fix the fault, while the perfective is used to improve the system, and the adaptive is used to introduce a new features for the system. In the past, the array method was used to classify commits into maintenance activity. This will make it difficult to extract the information from the array because it is not visualized. Therefore, by visualizing the maintenance activity, it can improve the way to extract the needed information that will assist the maintenance process. The visualization is used to detect the potential anomalies that will occur in the maintenance activity. This will reduce a huge amount of cost for software maintenance. The way software maintenance activity can be visualized are by using the stack bar diagrams. Each activity has a different type of colors, and all activities are stacked on top of each other. The x-axis is the timeline, while the y-axis is a commit count. Visualization can help many users that have a technical skill, such as a team members and a project manager, by providing a high level information. Okay, the last technical paper is titled as a code clone analysis to improve software maintenance process. This technical paper explains the way to improve the software maintenance process by removing or eliminating the code clone. In this context, a code clone is a code block that is similar to another code block. Code clone occurs after the developer or programmer copy and paste the code to reuse the code. This will make that copied code is dependent on other code, meaning that if one code block needs to be modified, then the other copied block also needs to be modified. Code clone have several drawbacks in the software maintenance process. Okay, firstly, it increased the difficulty to improve the system because it required additional time to implement the new improvement code without affecting another copied code. Second, it increased the probability of producing a new bug. This is because most of the code blocks have one function or purpose only. Therefore, it will lead to error prone and may produce new bug in the system. Lastly, it will increase the maintenance cost. This is because if the copied code block has a bug, of course, then another copied code block also needs to be checked to guarantee that there is no bug and it is safe to use. Therefore, it increases the time for maintenance, that also will increase the cost for maintenance.
Last but not least is our conclusion. So for our conclusion, software maintenance actually is a major cost for the software, and it must be planned for during the entire life cycle. Besides, information about hiding techniques is used in the design workflow. Then the coding style must be good for the implementation workflow. The documentation must be complete, correct, and current. Other than that, maintainability must not be compromised during maintenance. It is quite challenging and critical that the best people should be put on the task and rewarded accordingly. That's all from us about software maintenance process from our group. Thank you.